Hi friends, welcome to NetTalks Tamil. Today we are going to discuss about implicit rules and explicit rules in ASA. The implicit rule and explicit rule concept remains same for all the firewalls. Only the difference will be how those rules are configured in. It will be get differ from the OEM to OEM. The implicit rules. What is mean by implicit rule? It is a system defined out of the box rule. Okay, it is not created by any engineer or it is not created manually. Out of the box, that rule will be created. It is a system defined. It cannot be edited or deleted. If you take some of the firewalls, these implicit rules are hidden. In few firewalls, the implicit rules are visible. For example, if you take a Palo Alto, okay, the by last implicit deny rule will be enabled, okay, which we can see it. If you take in the ASA case, okay, by default implicit deny rules are not visible. If a explicit rules means it is a user defined. It is created by administrator. It is created by network administrator. It is a manually created. It can be deleted or edited. It can be customized. It can be modified. All those things we can play it in explicit rule. The whatever the normal port opening request, the day-to-day network engineer does, that's all called explicit. It is always visible. We can see in the firewall as part of access to access list or rules, all those things we can see it in the firewall, which is called explicit rule. See, if you more detail, if you see the implicit rule, they say the implicit rules, if you see out of the box, okay, lower, higher to low security level, the traffic is allowed. That is by default, it's allowed. All TCP UDP traffic is allowed from high to low security level. In this case, in this scenario, if you take inside zone having a security level of 100, outside zone having a security level of 0. From inside to outside zone, if I do telnet from R1 to R2, it will get allowed. By default, that is implicit allowed. Okay, those implicit rule, the TCP or UDP, which is allowed from high security to low security level, which cannot be visible in A. That is more we can discuss in the MPF, the modular policy framework that will be discussed, how the TCP and UDP allowed, all those things we will discuss in MPF. The explicit rule, which manually the administrator created from outside to inside or inside to inside, all the inside to DMZ, all those things are explicit rule. Those rules also we'll see in upcoming session. See, all the interface of ASA, it is can handle through traffic. Sorry, through traffic. All the interface of ASA can handle through traffic, except management interface. The management interface can handle only to traffic. By default, the management interface, it's allowed only to access this device. It cannot handle the traffic, whatever it's through. Through in the sense, okay, from inside to outside, DMZ to inside, all those things. Only through this interface we can handle this. This management interface we can call as a OOB interface. OOB means out of band interface. It deals traffic with two traffic, which is management traffic. Telnet, SSH, HTTP. Only the management plane traffic can handle it via this MGMT interface. Other interface can handle like a normal ingress, egress, all those traffic can handle it. That's where we call as through traffic. This only management can handle it to traffic. Okay, towards of ASA. The through traffic means okay, the traffic will hit and exit from the ASA. That is a through traffic. So let us see in the notes. The implicit rule, it's a system defined, out of the box, can be edit or delete. Some some firewalls, these rules will be hidden. In some firewalls, it is visible. In explicit rule, it's a user defined, manually created. It can be edit or delete, always visible. Let us see in detail in the lab. Let me turn on all the devices. Let us do the configuration from the scratch. Let us do the configuration from the scratch. For router 1, configuration config t or tr inside hostname, hostname or tr inside interface gi 0/0 IP address 10.11.11.0. Subnet mask is 255.255.255.0. No shut. Default route towards ASA IP route 0.0.0.0.0.0.0.0 10.11.11.10, which is I'm going to configure in the ASA. Now line VTY also will configure line VTY 04 transport input all transport output. This is for taking connection from inside to outside. Okay, just we are configuring line VTY transport and output all. Let me create a username password as well. Password Cisco 123. All the device will configure with the password as a Cisco 123. We will initially go with the telnet. The similar configuration we need to perform in all the devices. Let us prepare a configuration for all the routers. Router 2. Router 2 is my outside router. Outside router. This almost will remain same. Only necessary configuration will change it. Outside interface IP I need to change here 172.16.3.1, which is my router interface. Firewall interface IP is 10. Now configuration is prepared for router 2. Now router 3 configuration let us prepare. Router 3 configuration. DMZ 2 IP is 192.168.30.1. Here in router 1 I given as a network address. Let me change it. Gateway dot 10 dot 10. Now router 4, let us configure 40.1, 40.10. Rest all remains same. Now let us do the interface configuration of ASA. ASA, we are going to do only interface configuration and sorry. Before going to do ASA configuration, let us configure one by one router. It will take few minutes. That's why I'm logging in all the routers and hit entering. R4 is not coming up. Okay, yes. Now let us see router 1 is ready now. Enable. Let us copy paste a ready configuration. Yes, we have completed. Icmp. Now copy paste router 2 configuration. Now router 2 also ready. Now router 3, let us go. Let us copy paste router 3. Now let us configure router 4. Now all the routers basic configuration we have completed. Now let us start configuring our ASA. ASA is here core piece. Let us do configuration of ASA. Show interface. Be brief. No interface, nothing is configured. First interface is GI 0/0. Let us prepare the configuration. Interface GI config T. Interface GI 0/0. IP address 10.11.11.10. Subnet mask is 255.255.255.0. Security security level 100. Before that, if I give name if security, inside by default it will take 100. I no need to give manually security level 100. If I give inside, it will take by default security level as 100. Let me give that. We'll see here. See here, as soon as I given a name if inside, security level by default it taken as 100. For inside, we no need to give security level as 100. Okay, by default it will take. See here, it's a shutdown. Now I need to give no shutdown. Now next interface GI 0/1. One is outside. If I give outside, by default it will take as 0. So I no need to give here anything. Outside. IP I need to assign as 172.16.3.10. Now third interface GI 0/2. GI 0/2. It is DMZ1. DMZ1. For this, we have to customize the security level. Otherwise, it will take as a 0 default one. We need to get customized. Let me give as a 50. No shut. Now third interface G0/3. Here IP also need to get changed. 192.168.40.10 for DMZ2 3010. DMZ2. Now let us configure all the interfaces. Yes, now we have configured. Show interface IP brief. We give this command, we can able to see all the interface, what is the IP assigned. Show name if, we can see what is the zone, what is the security level as assigned. Let us ping the routers which is there in all the zones. Yes, we could able to ping. To ensure the connectivity towards the router is through from the firewall. To ensure We have not missed any configuration. I mean basic configuration. We could able to ping all the routers from ASA. Now let me do from inside to outside telnet. And now I have not created any rules in the firewall. It is plain firewall. Only I have assigned the IP address. Now let us do the telnet from inside to outside. What is the outside IP? It is the outside IP telnet 172.16.3.1. Sorry, I'm doing it from ASA, same which I need to do from the router 1. Telnet 172.16.3.1. I'm doing telnet from inside to outside router. Hit enter. Let me give Cisco 123. I could able to log in from router inside to router outside without allowing any policy. Why I could able to log in? By default, ASA allows high to low security level without any policy. That is implicit rule which is allowed in the ASA from high to low security level. Let me do from low to high whether I can do anything. Router 2 to telnet 10.11.11.g1. No, from low to high, it's not allowed. See, always high security level, it means it's a trusted zone. Okay, if low security in the sense, it is untrusted. For example, let me do from DMZ to DMZ1 to outside. This is level 50, here it's 1. Telnet 172.16.3.1. Yes, I could able to do telnet to the outside. See, from low to high security level, what and all possibilities? From inside to outside I can access, from inside to DMZ I can access, from inside to DMZ1 I can access. Why? Because the DMZ, both the DMZ having a security level of 50, but from outside, from low to high in the sense, I cannot access from outside to inside, from outside to both the DMZs. See, if you see here one catch is there, DMZ1 and DMZ2 having same security level. Whether same security level by default it's allowed? No. By default, same security level is not allowed. If I want to allow the same security level, I need to use a command as, let me show you that as well. DMZ2 to DMZ1, let me do the telnet 192.168.30.1 I am able to access. Let me check what is the security level I have assigned to the both the zones. Show name if. Oh, sorry, my bad. I pinged from the same router to same router. Let me do the telnet. That's what little bit I got confused. 192.168.40.1. I am from DMZ to DMZ 1. I am not able to do telnet. Why? Because the same security it's not allowed. Even though if I am creating ACL also, it will not get allowed. I need to enable one command in ASA. Let me get enable it. Config t same security traffic permit inter interface. Now let us try same thing. Now it will work out. Now from DMZ2 to DMZ1 is accessible. Here I did one misconfiguration for DMZ2 hostname we have given wrongly. Let me get corrected. To avoid a confusion, see now we could able to access from R3 to R3 to R4, which is DMZ2 to DMZ1. Earlier which could not able to access, now we could able to access. You may think why I am not doing it a ping, why I did a telnet, right? There is a catch here. By default, ASA from high to low security level, uh, same interface, all those things will be allowed. TCP traffic. Here one more catch is here. With the same security level, if I allow the interzone, even the ping will be get allowed. All the traffic, okay, it will not block anything. All the traffic will get allowed, which is not recommended. Always keep the same security level to avoid this. Okay, better to keep different security levels. For example, I'm keeping here 50, better to keep here 40 or 60. Why? Because if I allow the same interzone traffic, same security traffic permit interface, it will allow all the traffic. It will not get blocked anything. It will allow all the IP protocol traffics. Better to, as a best practice, we have to keep different security level for each and every zones. That is ideally suggested. Based on the scenarios, you can get design this. You may think, okay, if I did a telnet from R1 to R2, why I not done the ping? If I could have done the ping also easy, right? Why I not done the ping? See, in generally, the ping is not behave like a TCMP or TCP or UDP traffic. It will get blocked. For example, if client is accessing a web page on the internet, when a packet arrives inside interface from the client, the packet is categorized into a flow based on five tuples. What is a five tuples? The five tuples which contains source IP, source port, destination IP, destination port, and layer 4 protocol. Layer 4 protocol means it's a TCP or UDP, all those things, it will be having it. The ASA then maintains a state table to track this connection or flows. Based on this state table, the return traffic from source to destination or destination to source will be allowed through the firewall. So normally, whenever the traffic generates from here, by default, the TCP and UDP traffic is allowed from high to low security level, but that is by default implicit rule. When it sends, okay, the ASA will maintain all the session table. Okay, return traffic comes, it will look the session table and it will send it back. Back to the ASA and the ping. The ping is a part of ICMP protocol suite and handled differently compared to TCP or UDP. ASA does not track ICMP session or connection, make it stateless. Because ICMP packet do not themselves contain any connection or information, its being is stateless. The ASA will let the ICMP echo request from inside to outside. Usually the ASA will allow the from inside to outside ICMP, but will not allow the return traffic ICMP echo replay from outside to inside. It will not allow. If you want to allow this ICMP, if you want to allow the return traffic of ICMP echo reply, then we need to enable the ICMP inspection engine in ASA. ASA can track the ICMP session by enabling ICMP inspection engine. This result is an ICMP session being tracked in ASA, which turns allow the ICMP replay packets to pass through from outside to inside. The ICMP inspection can also dynamically allow the time exceeded and destination unreachable message to pass through the outside interface. See, when the traffic from R2 to R2, R1 to R2 goes, if I am not enabled ICMP inspection in ASA, it will allow, but return traffic when ICMP echo replay comes, the session will not get tracked. Since inspection is not enabled in the ASA, it will get dropped. That's why we could not able to ping from here to there. Let me go to the ASA, show policy map, show run policy map. See, by default, these are the policies enabled, but we cannot see here the TCP or UDP inspection is enabled. By default, that is implicit, it is getting enabled. We will discuss more about the TCP and UDP inspection get allowed. That is in MPF, we will discuss more into that. Here, ICMP is not allowed. Inspection is enabled, not enabled for ICMP. Now, let us enable ICMP. Yeah, before that, let me show you one more thing. Let me enable a debug from R2. R2, let me enable a debug. I debug IP ICMP. I have enabled the debug. Let me ping here. After enabling debug, let us ping here and see here in R2. We could able to see R2 is sending a reply back to the R1, but we could not able to see replay here. Why? Because our ASA is not allowing that traffic. Let me enable ICMP inspection in ASA. After that, We will see. Inspect ICMP, enter. Now let us ping. Yes, it's pinging. Now it's pinging. Let me stop the debug here. Debug. Now it's pinging. After enabling the ICMP inspection in ASA, we could able to ping the. Now there are two commands are there. One is like this to get enabled. Another way also is there. No, I have given. One more command is there. Fix up protocol ICMP. Yes, again it will get changed. It will get ICMP is added. There are two commands. One I can give as this way. Enabling ICMP inspection. Or this command. Even let me upload the configuration file also in YouTube. You can refer to it. See, this is in detail what is the ICMP inspection, what we discussed. Now you can refer through it. The ping is a part of the ICMP protocol so and handled differently compared to TCP or UDP. ASA does not track ICMP session or connection, making it stateless. Because ICMP packets do not themselves contain any connection information, being a stateless, ASA will let ICMP echo request from inside to outside. But it will not allow the ICMP echo reply from outside to inside. That's what, okay, we need to enable ICMP inspection to get passed through the ICMP packets from outside to inside, high low to high security level. This is the lab scenario. You can try it your own lab by using UNG. Let us catch up in next video. So thanks for watching NetTalks.